Welcome to the Computer Network series. Today's session is about CSMA, CSMA with CD and CA. These are the core rules and protocols that help computer networks share communication pathways, catch data collisions, and keep our internet traffic run very smoothly. Let's start with the basics. CSMA, which stands for Carrier Sense Multiple Access. This is a foundational rule for sharing network media. Simply speaking, before a device tries to send any data, it listens to the channel to see if anyone else is using it. Listen before you talk. That's the key takeaway to understand CSMA. Think of it like a group meeting in a conference room where there is only one microphone. But before you speak, you should listen. If someone else is talking, you should wait for your turn. If two people start talking at the same time, both stop and wait for a random amount of time before they try again. That's exactly what is CSMA. Here is how CSMA operates. A station checks the channel. If the channel is free, it transmits. If the channel is busy, it waits. Yes, if it is busy, it waits and it checks again later. But is this enough? Unfortunately, no. Collisions can still happen. Because of what we call propagation delay, the time it takes a signal to travel across a wire, two stations very far apart might both check the channel at exactly the same moment, see it as empty, and transmit simultaneously, which can lead to collision. Look at the picture. Station A and B senses the channel at the same time and then they start transmission. A collision resulted. So CSMA tries to reduce collision but cannot completely eliminate them. Yes? When the channel is busy, what should a station do? When a channel is busy, stations use different persistent methods. Number one is one persistent CSMA. With one persistent CSMA, devices constantly listen, continuously senses the channel. And the second the channel is free, they transmit, though this causes high collision rates if many stations are waiting. With non-persistent CSMA, devices wait a random amount of time before checking again. This reduces collision but adds delay. Finally comes the P-persistent CSMA, which is used in slotted channels, where devices transmit with a probability of P when the channel is idle and differ with a probability of 1 minus P. Fine. Next up is CSMA CD, which stands for collision detection. This protocol builds on regular CSMA by having different devices monitor the signal while they are actively transmitting. So if a collision happens, the device immediately stops sending data and broadcasts a special jam signal to alert everyone. CSMA CD is used in wired Ethernet. It cannot work on wireless because a device cannot transmit and listen simultaneously on the same frequency, is it not? Yes. How does CSMA CD work step by step? The device senses a channel. If busy, it waits. If it is idle, start transmitting. Monitor the channel while transmitting. Very important for CSMA CD. No collision, transmission is successful. If collision is detected, the device stop transmission, sends a special jam signal which alerts all the other devices, waits for a random back of time and then retransmit again. So now look at the example. A and B are transmitting. Collision has happened. After collision, the device would have detected the collision. It stops transmission, sends a jam signal, a random back of time it waits, and then tries again the retransmission. So what is this binary exponential back of time? To make sure devices don't keep crashing into each other, they use something called the binary exponential backoff. After every repeated collision, the random waiting range increases exponentially. For example, after the first collision, you pick a short wait time. But after multiple collisions, the possible waiting window grows larger to spread out the traffic. So that's given in the example. First collision, choose 0 or 1. Second, 0 to 3. Third, 0 to 7. Fourth, 0 to 11. So what is the purpose? Reduce the probability that the same stations never collide again and again. So how CSMA-CD prevents data collisions? Listen, transmit, detect collisions, jam signal followed by back off. So that's a key takeaway. Right. So look at the example. Two PCs A and B both detect an idle line and transmits at the same time. They signal collide, they spot the voltage spike. Stop transmitting, sends a jump signal and triggers a random back off timer before trying again. Yes, so this is how CSMA CD works. Done. Now there's a question. What about wireless networks? Maybe like Wi-Fi. Wireless devices cannot easily detect collisions while they are transmitting because their own signal completely drowns out incoming data. So because of this, Wi-Fi uses CSMA CA, which stands for CSMA with collision avoidance. So CSMA CA avoids collision proactively using signaling and timing. Number 1. Physical carrier sense. Check if the RF channel is clear before transmitting. Number 2. Virtual carrier sense. Use NAV timer to track when the medium is free. RTS CTS handshake. Reserve the channel with a request to send, clear to send exchange. Let's talk about this in detail. So CSMA-CA stands for carrier sense, multiple access with collision avoidance. This is mainly associated with wireless LANs. Why not simply use collision detection? Because wireless devices have the difficulty to detect collisions while they transmit. It is impossible for them to monitor collision while they transmit. So try to avoid collisions before they happen. So CSMA-CA proactively tries to avoid collision before the collision happens. That's the key takeaway. Why collision detection is difficult in wireless? Because we have already talked about hidden terminal problem and exposed terminal problem. A wireless station cannot reliably listen to any medium while transmitting and detect a collision in the same way as an Ethernet. Because of the hidden terminal problem, the characteristics of the wireless channel may vary. The signal strength at transmitter may overwhelm incoming signals. So all these factors contribute to the reason that collision detection is very difficult in wireless LANs. So therefore, the Ethernet uses CSMA CD, whereas Wi-Fi uses CSMA CA. Coming to the basic operation of CSMA CA. Sense the channel. Channel is idle. Yes, send. If there is collision, wait. Random back off, transmit. Wait for acknowledgement. If acknowledgement is received, transmission is successful. If acknowledgement is not received, assume collision or loss of frame. Go for exponential back off, wait again and retransmit. So this is what is the basic operation of CSMA CA. Yes. What is random back off in CSMA CA? Suppose multiple stations are waiting. Every station will choose a random back off counter. For example, A's back off counter is 2, B's back off counter is 5, C's back off counter is 8. So A reaches 0 first. Countdown starts 2, 1, 0. For B, countdown starts 5, 4, 3, 2, 1, 0. So A will reach the 0 first. Other stations freeze their countdown while the channel is busy. This reduces simultaneous transmissions in CSMA CA. How does acknowledgement look like in CSMA CA? Wireless communication commonly uses an acknowledgement. So if acknowledgement doesn't arrive, go for the back off and then start retransmission. Done. So what is this RTS and CTS? For wireless networks, request to send and clear to send can further reduce collisions. A sender sends the RTS before the data is being transmitted. Receiver sends CTS. Other stations hearing CTS now comes to know that we all need to stay silent. Someone is going to use a channel. Now the sender sends the data complete transmission gets the acknowledgement from the receiver and the data transmission gets over. So this is one other way where CSMA CA can further reduce collisions. Right. So this RTS CTS, as it is so important, is the NAV, which stands for Network Allocation Vector. So in RTS CTS handshake, sender transmits a request to send. Receiver replies with a clear to send. So reserving the channel for all nearby devices, right? What is this network allocation vector? Every device reads the RTS CTS duration field and sets a countdown timer. The medium is treated as busy until this timer reaches zero, NAV reaches zero, even if no signal is physically detected. So RTS CTS mechanisms along with the NAV mechanisms makes CSMA CA very proactive in collision avoidance. The hidden terminal problem itself is very important in understanding the mechanism of CSMA CA. In this example, A and C are devices where they cannot hear each other. If both sense the channel at the same time, they will find the channel as idle. They start transmission, collision occurs at the access point. RTS and CTS help solve this problem. So that is the significance of RTS and CTS in CSMA CA. So an example of Wi-Fi communication. Look at the handshake. This handshake solves the hidden terminal problem. Two devices out of range of each other can both communicate within the access point without colliding because the access point CTS silence both. So that is why CSMA CA is predominantly significant, right? To avoid crashes before they happen, wireless devices uses these clever tricks. To wrap up things, here is a quick rule of thumb. Use basic CSMA for simple listen before talk foundations. Use CSMA CD for traditional wired Ethernet, where you can detect collisions midway. And you use CSMA CA for wireless networks, where you must avoid collisions proactively. Any doubts? Post it in the comment section. Thank you. Happy learning.